This video is about angles in circles, okay, continued from last week. So in the first picture, this segment here is called a secant. And then this segment that goes from the circumference to this point, okay, intersects the circle in one place, and that is called a tangent. So you have two arcs here. This arc is 50 degrees. And then I have this arc, okay, arc AB, which measures 110 degrees. So there's a formula, okay, which you're going to have to memorize to get the number of degrees in angle C. So the measure of angle C is equal to half the larger arc, okay, we call that a major arc, minus the minor arc. Now, where do these come from? When you look at the intersection of the secant with the circle, okay, this part here up to this point of tangency, that's what we call that, point of tangency. So you're going to follow the secant, and then you have the part going from the further end point away from C over to B. That's the major arc. And then when you go from B over to, let me give this point a name, D, that's the minor arc. Okay, and that's how you would find the measure of angle C. All right, let's look at the next question. So in the next question, you have these tangents. So going from the circumference, it touches in one place. Okay, a secant passes through two places. So a tangent passes through one place. That is a tangent, and then this is a tangent. So I want to find the measure of angle B. Notice I only gave you the 200. Now the 200 is going all the way from A to C. It's the major arc. So to get the minor arc, you know how many degrees there are in a circle. Therefore, arc AC, the minor arc, measures 160. Okay, the formula is the same as in the previous problem. You're going to do 200 minus 160 divided by 2, or half, whichever way you'd like to write it. And that's the measure of angle B. Oh, I never gave the final answer here. Okay, so in the previous question, 110 minus 50 is 60, and half of 60 is 30 degrees. And then in this problem, 200 minus 160 is 40, and half of 40 is 20 degrees. Okay, so there you have it. So this is a tangent, and the previous problem was a secant tangent. Okay, let's continue on to the next slide. So in the top picture, you have an angle outside the circle. We call these angles outside the circle. That is formed by this secant, A, B, C. And then you have this other secant, EDC. It's the same formula. You have to follow the secant to the circle. Keep going across the circle. Then you take the other secant, follow it to the circle, across the circle. Then you're going to go from A to E. That's the major arc. That's 160. And then for the minor arc, you're going to go from B to D. That's 40 degrees. Be careful, sometimes the secant may pass directly through the center. So this is called the circle O. So just keep that in mind. So the measure of angle C is half 160 minus 40. Well, 160 minus 40 is 120, and half of 120 is 60 degrees. So this measures 60 degrees. Okay, in question number 4, in this picture, I marked off that EB was congruent to DB. Okay, what do we call EB and DB? That is correct, we call them chords. So you have this other chord, which is the longest chord in a circle because it passes through the center. We call that a diameter. So when you have a diameter that you form these congruent parts of these chords for EB and BD, the only way that can happen is by creating right angles. So these are all right angles here. So that can come up integrated within a problem. So you just need to know that fact. Okay, question number 5. We have 2 chords. We have chord A, B, C, and then we have chord E, B, D. Okay, they intersect at B. Sometimes they'll have them intersect in the center of the circle. Here they don't intersect in the center of the circle. So if I'm looking for this angle here, okay, if I want the measure of angle ABE, which by the way would be the same as the measure of angle DBC. Okay, what I would do is I would use the formula half the sum of these intercepted arcs. So this arc intercepts this angle. This is not a central angle, okay? And then this arc intersects this angle. So, all right, I have half of 60 plus 50, and half of 110 is 55 degrees. So that would be the measure of angle ABE and DBC. Okay, keep in mind this could have passed through the center. We could have used 180, a semicircle. There can be other things that are incorporated into these problems. So I'm taking a look at the next question on the bottom of the page here. I have a radius AO, and that radius is drawn to this tangent BA. Here's the point of tangency. When you have a radius drawn to a tangent, it will always create a right angle. So the Pythagorean theorem could be involved in a question like this. Okay, that would be a right angle, but say this was 8, and say that this is 15. The measure of OB, okay, you just use the Pythagorean theorem. You do 8 squared plus 15 squared equals x squared, yada, yada. Okay, this would come out to be 17. But just keep in mind that whenever you have a right angle, you could have the Pythagorean theorem involved. Okay, taking a look at the last question, and then I'm going to review the previous lesson. In this picture, I have parallel chords. This is circle O. So when you have a chord that passes through the center, it is called the diameter. Okay, so this is a diameter AB. Okay, now as you know, a diameter splits the circle in half, so you would have 180 degrees, right? Well, I have this 40 degrees for, let's call this arc DE. That measures 40 degrees. So I already know that a semicircle has 180 degrees. And the fact that you would need to know here is that parallel chords intercept congruent arcs. Okay, so what does that mean for us? That means that DA and EB are equal. So I'll call them both X. So if I want to find the measure of arc AD, what I would do is I would do X plus 40 equals 180. 2X equals 140, so X is 70 degrees. All right, and then the measure of arc EB would be the same thing. But if you're given a question in math and you can't just solve it, that means that there's other information that you should have in your toolbox that you'll have to use in order to solve the question. So this is review. So for the review, what we had done last class, we had discussed that a central angle has the same measure as its intercepted arc. So that would measure 75 degrees. An inscribed angle measures half of its intercepted arc. So this would be 50 degrees. Half of 100. Vice versa, of course, the intercepted arc would have twice the measure as the inscribed angle. Keep that in mind. And I had mentioned last class that whatever angle you have inscribed to an arc, every angle that is inscribed to that arc must be congruent. These are all congruent. Okay, in this problem at the top of the page, I have an angle inscribed in a semicircle. That's straight memorization. An angle inscribed in a semicircle will always be a right angle because half of 180 is 90 degrees. And when an angle measures 90 degrees, we call that a right angle. A cyclic quadrilateral. When we're dealing with a cyclic quadrilateral, I'm just reminding you that opposite angles add to 180. Okay? So just keep that in mind, because in any geometry problem, there can be multiple skills that they test you on at once. And I would, in fact, make an argument that that happens in the majority of math problems. So just the last page that is review is, remember I did area of a sector. So area is pi r squared. Then you would take your angle. So let's say that this angle is 70 degrees. Okay, this central angle. You would do 70 over 360, because there's 360 degrees in a circle. And then you would have to substitute in your radius. So let's say the radius is 8. So you'd have 70 over 360 pi 8 squared. And you could type that into your calculator. So the length of an arc, let's say I want the length of this arc here, which is a piece of a circumference. I would take my circumference, which is pi d, and I would do the same thing. So let's say this measures 50 degrees. I would do 50 over 360. And then I would need my diameter. So if my radius is 8, what would my diameter equal? That's correct. Okay, so there you have it. And just keep in mind, I know it seems ridiculous, but we're all human. We make careless errors. 8 squared is 64. Big difference between doubling a number and squaring a number. Okay? Diameter is twice the radius. All right. Thank you very much.